Hello. Let's start with this. So one of the first thing that comes to our mind when we think about electricity is charge. Here I have a comb. You can try this at your home. We need some paper. So you have to take some paper, a comb, just comb your hairs like this. My hairs are not oiled, so probably it will not happen. To just comb your hairs, and then you have to place this comb over the bits of paper and they'll get attracted. Now while you're combing, have you ever thought why this thing happens? You might have seen this in your life practicals. So one of the main reasons why this happens is because when you're combing your hair, the comb gets charged. As electrons jump between your hair and this comb, your hair gets charged and your comb gets charged. And these two charged objects together, and they are oppositely charged. Okay, if one is positively charged and another is negatively charged, like charges, they start attracting, and that's the very reason that it develops an electrostatic force. Like due to electrostatic force, this charge attracts small bits of paper. That's why you can, because the force is not that much that you can attract a whole piece of paper. It's not magnet. Magnet does not use that force. Now, I'll tell you the reason why my clip might appear to be grainy. The reason is that I'm using the webcam and I'm streaming from laptop. So you must be knowing that webcams are not that great while streaming. So charge. What is charge? Let's come back. Any quantity, electricity is light. Charge? Of course, charge, due to charge. But have you ever thought what really charge is? The charge is, remember this, charge is the physical property of a substance, like of everything, okay, caused due to disbalance in the number of electrons. Charge occurs due to deficiency or sufficiency of electrons, because when there are excess electrons it gets negatively charged, and when there is a deficiency of electrons it gets positively charged. So this is the first thing, charge. The second thing that comes to our mind when we talk about electricity is, okay, so I know what is charge. What is electricity? You think that is keeping this light on, that will work, that will make my AC work? Yes, of course. So now what is electricity? If I take this piece, this is a copper wire, copper wire, and I connect this thing to the socket, I know for sure I'll be, all hairs will be straight and smoke coming out of my body, but some energy will pass from that socket into my body, and that means that I can conduct electricity. So the motion of charge, I told you what charge is. Motion of charge produces electricity, and so the rate of flow of charge across a conductor or any substance, the rate of flow of charge is called electricity. So you might be thinking, if charge goes from one direction to the other direction, the electricity must be flowing in that direction. Remember this is false. This is not true that the charge and electricity move in same direction. Understand? This is a piece of copper wire. If the charges are moving from this end, charges, then electricity, and you must be understanding that the charge always moves, like the charge which moves is always the electrons, because protons are present deep inside the atom. You have studied this in last year in the structure of atoms chapter, that proton is present in deep inside the atom, so it cannot be moved. Electrons which revolve around the atom, they are released and they move. So If electricity goes from this end to this end, then if charge goes from this end to this end, then electricity will go from this end to this end into this small Tesla coil. Okay, so this was charge. I'm not going to tell you the formulas for these things. You can find them in the book. Okay, I'm just here to explain you what it means. Now you must have thought that electrons exist in these copper wires. This is a copper wire, very thin piece of copper wire. See, so charges, electrons are present in this copper wire. Why I cannot see electric current here? Have you ever thought this question? Come on. Just take some moment and think. If electrons are present, and then what makes the electricity flow? For this, you need to understand the concept of potential difference or electric potential. This is a battery, a 9-volt battery. It's not written. Yes, it's written here. See, 9-volt battery. So in a 9-volt battery, what does the potential difference, the volt, signify? So for doing any, like you all wake up, you go for work, you do other things in the world. It requires some energy, you know. You eat the food to get the energy, and then you get the energy to do the work. Whenever you're tired, you say, oh, I need some energy to work. Energy. The amount, now I'm telling you what is electric potential. The amount of energy required to move unit positive charges. These are definitions. You need to remember them. Yes, you need to remember them. There is nothing. But if you understand the concept, you will be able to remember the definition very easily. The amount of energy required to move unit positive charge from infinity to the point is known as the electric potential of the point. And the amount of energy required to move the charge between 2 points in a circuit or in a conductor is known as the potential difference between the points. Again, I'm back here. This point and this point, they both must be at different potential for electric current to flow. You know, the potential of Earth is 0. So if I just connect this wire from my socket to the Earth, the current will flow because that socket is at 220 volts of potential and Earth at 0. So current will flow. Now, electric potential I have covered, electric potential difference I have covered, energy. So, and I shall tell you that the formula for potential difference is work done per unit charge, like per charge moved. So I will show you here. This is called a battery, and it consists of many cells. See, it's all empty here. So there were cells. Now due to leakage, I've thrown that part. Otherwise, I would have shown you. Every battery consists of cells. A group of cells is called battery. Now, cell and battery are the two things which are required to keep this machine, to maintain the potential difference. And that's why it provides the current as well as it provides the required potential difference. It is the device used for maintaining the potential difference. Okay, so I'll show you a little demonstration here. Yes, one more is required. Okay, I'm using this as see. Okay, yes, it will emit light. I guess you will be able to see this. It's very common. This is a bulb. Okay, this here, this thing. This is the battery. I hope it is working. Probably at wrong points. I'm playing it. See. Now, let me show you from close. Look, this thing, this little guy here, it's a circuit. This was part of a mouse. So If you look closely enough, there is some potential required to help like the electrons when the potential difference is required to make the current flow. Just imagine if this point has same potential and this point has the same potential, then will the current flow? No. If there is no difference in the energy required in the 2 points, then how can you expect the current to flow? So that's the potential difference. I've shown you what I've told you till now. The charge, what is electricity, the relation between charge and electricity, the relation between electricity and potential difference, and what is use of this little guy, battery. Okay, so I'll show you potential difference, and there are devices used for measuring different stuff. So for measuring the current in a device, we use a device called ammeter. Remember, always in a circuit, ammeter is connected in series. The reason you will get to know later in the chapter. And to check the voltage in a circuit, we use voltmeter, which is always connected in parallel. This is called a multimeter. There it consists of, see, it might not be too clear, ammeter, voltmeter, and it also measures the resistance. Where is the resistance? Yes, this is resistance. So I'll show you the voltage here. The voltage might not be 9 because it's an old battery, and as the battery ages, the potential difference decreases slightly. Hmm. So which one is positive? It's negative. See, it's 8.26. The potential difference exists in the battery. It's slightly less because it's a very old battery. You also might want to know the current. So ammeter. Now this is an electric one. Usually in the physics lab, it's a digital one. In physics lab, you will get to see something similar, but it will be a classical one, mostly a classical one. Okay, so actually, yeah, it's very difficult to keep the connection and see the change. Okay, as I put it. See. This change, it's giving some reading. Even I'm not able to read it properly. Okay, I've told you this is completely exhausted, nearly at the end of its life. So some value is given here. Okay, and also I also want to show you in beginning of the lesson I told you that if I put my finger inside the socket I will get hurt. Do you know your body also has potential? See, my body current, but the current does not flow because I'm made of cells. Okay, so I've told you what is voltmeter, what is ammeter, what they are used for, what is battery, and the next thing is one of the most important things is what is resistance. Have you ever thought whenever you move by a car, there is some traffic in the way, and you get struck due to the traffic, and then it feels like oh everything has stopped. So you get some obstructions and to your flow. Okay, similar obstructions are present in the copper wire, not only in copper wire, every substance. Here I'm showing you the copper wire. So a wire, this is a wire. See, the obstruction offered by a conductor to the flow of electrons is called resistance. Now substances are of three types: metal, which are called conductors, which allow smooth flow of electricity, and thus, remember, they have extremely less resistance. Okay, we have the alloys. You know what this is? This is the coil of a heater. You must have seen that heater thing. It's an alloy. It's called nichrome. Nichrome wire is the wire. These, like, it's an alloy. So alloys are the substance which have moderate amount of resistance, and they allow the flow of electric current. But you must have seen it provides a lot of electric heat energy. So a lot of heat energy is produced in the conduction. And lastly, plastic. No current will flow because it's an insulator. So insulators do not conduct electricity because their resistance is very high, extremely high. We call it extremely high because no current will flow through it. Now the cause of resistance will be studied later when you study the path, like on which factor resistance depends. Now I'll show you the resistance. Okay, I've never did it myself even though, but I hope it will happen, because it's very difficult to just keep all these things together and show them on the screen. But I have nothing to hold this device. And okay, so one end will be this. It's really difficult. I had no initial planning. First, let me just do this. Yes. Okay, so first let me see is reading something. Okay, there is some reading, but I'm telling you, it's very difficult for me to just do this. So what I'll do is I'll post some photos on the group with I'll post some photos in thumbnail probably of this reading. Okay, so I'll show you the readings so that you can pause the video and see the thumbnail to get the video, the photo. Okay, let's not go to this. And last thing which I want to tell you today is on the factors on which the resistance of a conductor depends. First thing is heat. As the temperature increases, the resistance increases. As the length increases, the resistance increases. Okay, for this point, I have one example. Have you ever gone through those small roads within the colonies and between? If traffic comes to that road, it will be blocked, totally jammed, and a lot of obstructions, high resistance. And whenever you will have an expressway, wide road, traffic flow will be smooth. So low resistance. So based on thickness and or the area of cross section, see, area of cross section, this area. Or I have something more thick than this, thicker than this. No, I don't have anything thicker than this. Okay. Yes, I have. Area of cross section. See, this thing, this part, this cut part. Okay. So area of cross section or the thickness. So as the area of cross section increases, the resistance decreases. Remember, resistance decreases. Temperature increase. Length, this thing will have less resistance than this wire. See, compare the length. This thing will have less. And if we compare this wire to this wire, can you see this? It's as thin as your hair. So this wire will have more resistance than this wire because it's thick. As the area of cross section increases, the resistance increases. And lastly, resistance depends upon the material. This is copper. Copper has good, like fairly good resistance. It's the second best conductor present there. I don't have silver here, but I do have aluminum. See, aluminum is mostly used in these type of things, cheap things, and it has slightly less slightly more resistance. Sorry, slightly more resistance. Okay, than copper. So this thing has slightly more resistance and it's better. Also, this fact that it's like this fact that things have different resistances and they depend on the material. Material to material they vary. You must not say that if anything the least a substance has resistance, the better it is. Because I accept the fact that for the flow of electricity, less resistance is necessary. But when you are thinking scientifically, remember, if there were no alloys, no heaters. If there were no plastic, then no switchboards, everything will be metal and high risk of electric shock. So when concerned about electricity, low resistance is good. That's why we prefer using copper wire in our wirings. We whenever we choose AC, we go for copper. We